So looking at the acceleration due to gravity or the gravitational field intensity, we can say that it is referred to as the force per unit mass of an object, and it is responsible for the weight or the force an object experiences on the earth. Okay, we can recall from what we have initially about the force of attraction that force is equal to Gm1 m2 over r squared. Since we are considering the acceleration due to gravity and this revolves around the earth, we can say that F is equal to G m e m all over r e squared, where me is equal to the mass of the earth. When we talk about gravity, it is the force that pulls an object towards the center of the earth. So earth is involved. So we're going to consider the mass of the earth in this case and the radius of the earth. So Re is equal to the radius of the earth, and m is the mass of the body. So we can say m is equals to the mass of the body. Okay, since we said that acceleration due to gravity is the force per unit mass, so we say that G is equal to force over mass, that is force per unit mass. And we know that F is equal to, so since F is equal to Gmem over Re squared, therefore we can say that G is equal to Gmem all over Re squared divided by m. Okay, everything here is equal to F, then divided by m. So because G equals F divided by m, so we have something like this. Is that okay? Now if you solve further, we have that G is equal to Gmem over Re squared times 1 over m. Of course, m is going to cancel out m, and then G will be equal to Gme over Re squared. Remember, we said that G is the gravitational constant, Me is the mass of the earth, and then Re is equal to the radius of the earth. And this is how we calculate for our acceleration due to gravity or the gravitational field intensity. So from Newton's second law, we have that F is equal to mg. Remember, if F equals mg, therefore G is equal to F over m. That was where we got the relation from. Is that okay? So the most important relation we have over here is this, and this is what we can use to calculate acceleration due to gravity if you are given the mass of the earth, the radius of the earth, and then of course we know the gravitational constant. Okay, but if you're not given all these parameters and you're just given the force and the mass of the earth directly, you can find your acceleration due to gravity from it using this relation over here. So how can we apply this in practical problems? Let us consider the examples below. We are told that the mass and the weight of a body on the earth are 80 kilograms and 80 newtons respectively. Determine the mass and the weight of the body respectively on a planet where the pull of gravity is 1/8 times that on the earth. This is the problem that we have, and we can solve this. It is very, very simple. What is the first step to do in any problem is to bring out your parameters. Why do we have to bring out the parameters? It helps us to know the exact relation to use. Okay, now since we have that the mass is equal to 8 kilograms, and we were told that the weight, remember weight is a force, so we can say the weight is equal to force, which is equal to 80 newtons. Okay, now we are asked to find the mass and the weight of the body respectively on a planet where the pull of gravity is 1/8 times that on the earth. So what is the first thing to do? Remember or recall that W is equal to mass times acceleration due to gravity. Why is W equals acceleration due to gravity? I'm sure we are used to having it this way. F equals mass times acceleration due to gravity from Newton's second law. Okay, from Newton's second law of motion, we have this. But remember, I said that weight is also equal to force. Okay, and that is why we can say, or we can have it like this. Okay, so we have W equals this. Now, we know the mass, we know the force or the weight, but we don't know the acceleration due to gravity. So we can compute the acceleration due to gravity from here. Therefore, G is equal to W over M, which is equal to 80 over 8. And this gives us 10 meters per second squared as the acceleration due to gravity. Okay, is this what we are looking for? Of course not. We're asked to find the mass and the weight of the body respectively on the planet if the gravitational pull is 1 over 8 times that on the earth. So the next thing to do is, remember we said that G is equal to 10 meters per second squared. But we have to look for the mass and the weight when, let's say, GE is equal to 1 over 8 of that on the earth. Okay, so we'll not confuse GE as the acceleration due to gravity of the earth. Let us just make it G prime. Okay, so let us have it as G prime. Right, but what is the acceleration due to gravity on the earth? Of course, it is 10 meters per second squared. So G prime will be equal to 1 over 8 times 10. Okay, which is equal to 10 over 8. And this gives us 1.25 meters per second squared. So this is the acceleration due to gravity on the planet. But is that still our answer? Of course not. Our answer is to find the mass as well as the weight. Okay, so how do we find the weight? Okay, let us find the mass first. 1. Without solving this, we should know that the mass remains constant because the mass of an object do not change irrespective of the location. That is the major difference between mass and weight. Weight changes, but mass remains constant. Therefore, mass on the planet will be equal to the same mass on Earth, which is equal to 8 kilograms. All right. So the next thing to find is the weight. We said that weight is also equal to mg, which is equal to force. All right. I've established that fact while we were dealing with the first part of the question. All right. So what is our new mass? Our mass will be equal to 8 kg times our acceleration due to gravity is no more the normal acceleration due to gravity, but the acceleration due to gravity on the planet, which is the G prime. Okay, so what is G prime? We have it to be 1.25 meters per second squared. So therefore, our weight is equal to 10 Newton. So this is where we will stop for today's class. We've been able to see how we can relate the acceleration due to gravity to force, as well as using the knowledge we have to solve practical problems. I'm sure with this you can solve as many problems as possible. But in case you still have worries, you still have issues, we are always here for you to attend to all your worries. So you can drop your questions on the platform as we will attend to them as soon as we see them. So till we'll meet again where we will discuss escape velocity. So just take care of yourself and see you in the next class.